Sorry about that. And lines called edges that join pairs of vertices okay, so vertices are like A, B, C, D, E, okay? Lines are the things between the 2 points. Those are called the edges that joins pair of vertices. So A to C, C to E, so on and so forth. D to E doesn't necessarily have to be a straight line. Okay. Certain types of graphs are called networks. Okay, so if you'll look at the diagram at the left, that's a graph. Identify the vertices. So see if you can label all the vertices. And I kind of did that already for you, didn't I? All right, so the vertices are A, B, C, D, and E. Okay, how many edges are in the graph? So pause this for a minute and count and see how many you get. Okay, I'm going to count them and see if you get what I got. I'm going to count the ones on the outside first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 edges in this graph. Cool. All right. So I'm going to put right here a little note that says the place where AD and BC intersect is not a vertex. Okay, because if it were a vertex, it would be given a point. Okay, but it doesn't have a point listed there, so it's just where the 2 lines cross. It's not an actual vertex. Now, if you look here and look here, this looks much more organized and calm than this. But this is the same as this because it has the same vertices and the same edges. It has AD, has AB, has AC, has BC, has BD, has DE, it has CE. It has all the same edges and the same vertices, but it's much neater. So let's put some notes here. We could draw figure A as figure B because this graph contains the same vertices and edges. Okay. The important information comes from vertices we connect by edges. The placement of the vertices and the shape of the edges are unimportant, excuse me. Okay, so where they are is unimportant. Even though that looks like a hot mess express, it's unimportant. Okay, this is just a little easier to read. Okay, but figure B looks awkward. So it's best to redraw it that looks like one word. Hang on a minute. I know it doesn't matter to you guys, but it looks a little silly to me. And present the information more clearly. Okay, and if you need to pause that so you can get that, feel free to do so. Okay. All right. And we're just going to fill out the rest of this sheet, and that'll be all the notes for today. And the rest of the notes in the packet will be for the next day. So, a vertex of a graph is odd if it is the endpoint of an odd number of edges. Okay, so if you've got 3 lines coming out of a vertex, then that vertex is odd. Okay, and as you can imagine, a vertex is even if it is the endpoint of an even number of edges. And I need to put in here, in case of counting vertices, 0 is considered even. Okay. In general, the degree of a vertex is the number of edges joined to that vertex. All right. Now, this is important. Euler's theorem. A graph can be traced if it is connected, okay, and has 0 or 2 odd vertices. So if they ask you, can you trace it? You look at it, instead of doing that whole trace your pencil around thing, like those little mind games, you can go, okay, how many vertices does it have that are odd? And if you have 0 or 2 odd vertices, it can be traced as long as all the vertices are connected. So I'm going to take a minute and use my highlighter and put a graph can be traced if connected and has 0 or 2 odd vertices. Okay? Okay, and that's Euler's theorem. All right. Now, I'm going to draw a figure here. It's going to look like an old school house. Okay, you got a triangle connected to a square. And we have A here. We have B here. We have C here. We have D here. We have E here. And then F's just kind of hanging out here in the middle. Okay, so this would not be able to be traced because it's not fully connected. No matter if it has the 2 or 0 odd vertices. But the 3 things that we're going to look at here is we're going to look at the degree of each vertice. So of A, B, C, D, E, and F. Then we're going to look at if it is odd, which ones are odd, and which ones are even. I guess I should have done that in red, but it'll be okay. All right, so the degree of A has 2 vertices coming off, two edges coming off of it, so that also makes A even. B has 1, 2, 3. 3 edges coming off of it, so it makes it odd. C has 1, 2, 3. So it is also odd. D has 1, 2. So that makes that even. E has 1, 2. So that makes that even. F has none. And remember that 0 is considered even. I told you, if you can count, you can do this. So, using Euler's theorem, state which of the following graphs can be traced. For a graph that can be traced, list a sequence of vertices that describes how to trace the graph. For a graph that cannot be traced, state which part of the Euler's theorem fails. All right. Now, let me remind you what a connected graph is. Okay, to be connected means you can travel to any other vertex by moving along successive edges. So I can get to any vertex. So the reason this didn't work is I can never get to F. Okay? All right. So we're going to have to do our degrees and our evens and odds to see. All right. So I'm going to do this one the way this other one should have been done. So we're going to do the degrees of each. So we have A, B, C, D. All right. Then we have odd and even. So A has 1, 2, 3, 4. B has 1, 2, 3, 4. C has 1, 2, 3. D has 1, 2, 3. So C and D are odd. A and B are even. Now, is the graph connected? Yes. Okay, there's no like random points hanging out there. Okay, so are there no or 2 odds? So when we look at the odds, there's 2. So yes. So yes, this can be traced. Now we have to find a path that will allow me to touch every point and get back to the original point. Okay? Now there's a bunch of different paths you can take. All right. So we need to touch every edge. Okay? We got to touch every edge. So we can do CBA. We don't have to touch every edge. We got to touch every. Hang on just 1 second. I've got to take care of something. Sorry guys, I got a little distracted. So when we're looking at this, we're going to start at a point and come back to that point. So let's just start with A. I can go A to B, and as long as we touch every point, we're fine. A to B, to C, to D, and back to A. Okay? Or I could have went A to B, to D, to C, to A. It doesn't matter. There's a bunch of paths. It just said provide one. Okay? Now, let's go to the next one. The degree. A, B, C, D. And we have odd. And we have even. All right. So on this one, A has 1, 2, 3. B has 1, 2, 3. C has 1, 2, 3. And D has 1, 2, 3. So odd is A, B, C, D. Even is none. So you go, is it connected? Yes. No, or 2 odds. It has no evens, but it has too many odds. So this is where it fails. And it said list what part of it fails. So it fails because of that. Okay, so easy peasy lemon squeezy. So we can't do a path for that one. All right, that's all for today. Let me know if you have any questions.